Today we'll be looking at the concept of velocity time graph. We'll talk about velocity time graph. Means that velocity is on the y-axis and time is on the x-axis. Velocity time graph. And what are we really talking about? Velocity time graph, one is trying to describe acceleration because acceleration is the rate of change of velocity. Velocity time graph. Similarly, when you talk about distance time graph, assuming distance is here, time is here, we are describing speed because speed is the rate of change of distance. And the same way, if you are talking about displacement time graph, what we are describing will be or is the velocity because velocity displacement, rate of change of displacement. So in this case, we have a problem to solve here, and there's a sketch. Most of the times, the sketch will be like this, and the question will be asked, calculate this, calculate that. And from here, we have this sketch. Is 0, the origin A, B, D, E, C. 0, A, B, C, D, E. Calculate the distance traveled from 0 seconds to 10. Calculate the distance traveled from 10 seconds to 25. Calculate the distance traveled from 25 seconds to 30. The total distance traveled, the average velocity, the acceleration for the first 10 seconds, and then the acceleration for the last 5 seconds. So what do we do? We need to be smart. We have a right angle triangle here, that is AD, 0 AD. Then the second one, then we'll have a rectangle here, ABDE. And the last one, we'll have another triangle here, BCE. So if we are able to calculate the area of this triangle, the area of the rectangle, the area of the last triangle, then we'll be solving the problem. Calculate the distance traveled from 0 to 10 seconds. So let's consider A, consider triangle OAD, which is this OAD. So the area of a triangle is half base times height. Half base times height. So this will be half base times height. Now what is the base here? The base is 10, the height is 20. So this will be equal to half times 10 times 20. 2 here 1, 2 here 5. That will be equal to 5 times 20 is 100 meters. So the distance traveled from 0 seconds to 10 seconds is 100 meters. The next one is distance traveled from 10 seconds to 25. So consider the rectangle ABDE. ABDE. What is the formula for calculating the area of a rectangle? It's length times breadth. This will be equal to L times breadth. And what is the length in this case? The difference between 25 and 10 is 15. And the height here, or the breadth, is 20. So that will be 15 times 20. And if I multiply that, that should give us 300 meters. Then the C part of it, Calculate the distance traveled from 25 to 30 seconds. So we'll consider this triangle BCE. Consider BCE, which is half base times height. So what is our base here? 30 minus this will give us 5, and the height is still 20. So that is equal to half times 5 times 20. So 2 here, 1, 2 here, 10. So 5 times 10 is 50. So this is equal to 50 meters. So the D part of it, the total distance traveled, will now add up 1, 2, 3. So total distance traveled will be equal to 100 plus 300 plus 50. And that will give us 450 meters. We have not finished. E is the average velocity. What is average velocity? In one of the classes, we talk about equations of motion. I will say that total distance is average velocity times time. So this is what we call the average velocity. So we can say that S is equal to, when we write something like this, it means average times time. So the average velocity will be equal to S all over T. That's the total distance traveled over the total time covered. This is equal to total distance all over total time. And what is the total distance? It's 450 meters. So this will be equal to 450. And what is the total time from here to here is what? 30. That will be 30. So this will be equal to 15 meters per second. That will be the average velocity. So they say acceleration for the first 10 seconds. Acceleration for the first 10 seconds. So the acceleration, that is F, for the first 10 seconds. Acceleration means velocity all over what? T. And the velocity here is what? 20. And the time is what? So this is the slope we're talking about. The slope of this gives us the acceleration. So that will be 20 minus 0, which is equal to 20 minus 0 all over 10 minus 0, which is equal to 20 all over 10, which is equal to 2 meters per second square. Then the last one is the acceleration in the last 5. At this point, it is now decreasing, so we'll call it retardation or deceleration. So that will now be equal to 0 minus 20 all over 5. All right. So here now will be equal to minus 20 over 5, which is equal to minus 4 meters per second square.